Today we have to study elastic collision in one dimension. Now what's an elastic collision? An elastic collision is the collision in which both kinetic energy and momentum of the system of particles is conserved. That is, the sum of the momenta before the collision of the two particles is equal to the sum of the momenta of the two particles after the collision. Same happens with the kinetic energy, that is the sum of the momenta of the kinetic energies of the two particles of the system is equal to the sum of the kinetic energies of the system after the collision. That is, if the collisions are perfectly elastic, then the sum of momenta before the collision, that's m1 u1 plus m2 u2, that will be equal to the momentum of the system after the collision, that's m1 v1 plus m2 v2. So if we substitute it, if we transpose this side m1 v1 to this side, we will obtain m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Now taking m1 common, we will have m1 into u1 minus m1 into u1 minus v1 is equal to, taking m2 common, m2 into v2 minus u2. Moreover, since the kinetic energy of the system is conserved, so we can say half m1 u1 square plus half m2 u2 square is equal to half of m1 v1 square, that's the kinetic energy after the collision. That's half m1 v1 square plus half m2 v2 square. Now if we are transposing it accordingly, then we will obtain half of m1 u1 square minus half m1 v1 square is equal to half m2 v2 square minus half of m2 u2 square. Now taking m1 and half common, we will obtain m1 u1 square minus u1 square is equal to m2 v2 square minus u2 square. 1 by 2 will get cancelled. Now using the formula of a square minus b square, we will have here m1 into u1 minus v1 into u1 plus v1 is equal to m2 into v2 minus u2 into v2 plus u2. Now dividing second by first, we will obtain m1 into u1 minus v1 into u1 plus v1 divided by m1 into u1 minus v1 is equal to m2 into v2 minus u2 into v2 plus u2 divided by m2 into v2 plus u2. m1 into u1 minus v1 and m2 into v2 minus u2 will get cancelled. On the both sides, we will have u1 plus v1 is equal to v2 plus u2, v1 is equal to v2 plus u2 minus u1. Now let's name this thing as A and this thing as B. Substituting the value of B in A, we will obtain this thing m1 u1 plus m2 u2 is equal to m1 v2 plus u2 minus u1. Now we are taking the terms that contain u2 on one side and other terms on the other side. Now this will get minus m1 u1 will get added with this m1 u1, we will obtain 2 m1 u1 plus m2 u2 minus m1 u2 because we are transposing the sides, and then we will obtain v2, we will take the v2 common, v2 into m1 plus m2. On the left hand side, we will obtain 2 m1 u1 plus u2 into m2 minus m1, and then v2 will be equal to 2 m1 u1 plus u2 into m2 minus m1 divided by m1 plus m2 because we are transposing it. So that's how you can obtain the final velocity of the object, knowing the initial velocities of the object in the head-on collision, in the one dimension, in the perfectly elastic type.